Today, robotics at Berkeley covers some amazing new directions. Flying, swimming, aircraft, rotorcraft, cars, submarines, floaters, and minimally invasive surgery, millimeter scale robots. You saw some of them flying around there and crawling here and so on, and robotics for design and manufacturing.
We're very interested in, as we think as the robots get smaller, they can go all sorts of places that people can't go. Say there's a disaster situation, an earthquake, and collapsed buildings. And of course, these robots aren't going to directly pull anyone out or rescue anyone. But if the robot can crawl through and find that there's someone trapped who's still alive, and all they need to do is to have a sensor to sense someone's alive, they're breathing, maybe putting out some carbon dioxide, and have a way of communicating that information out, then you know where to look to dig someone out, and you may be able to save lives.
We've also been really interested in how robotics can be applied outside of the in these normal environments that you might think of, and one is in fact in social media. So we have been thinking about a problem there, which is about basically, maybe most of you know, but it was 1953 when the term brainstorm was coined. And what's amazing is that in the past 60 years, the process really hasn't changed. We still do the same procedure. And we've been thinking about how we could scale that up to very large numbers of people online, and do brainstorms with hundreds or thousands of people. And the problem is when you scale, you sacrifice speed. It becomes very hard to filter out and find the needles in the haystack. So we've been pondering that. It turns out that there's a lot of things we can learn from robotics, because robots have to work in nonlinear environments, and they also have to deal with noisy dynamic data. So they have to filter data. And so we've developed a new system that we announced yesterday that is called the process called collaborative discovery. And it's an online website that's called hybridwisdom.com. So we just launched a startup.
I'm interested in automating a lot of what the air traffic controllers do manually. And I'm interested in flight control, and I work a lot with Boeing, for example, on automation in cockpits and in airplanes. And these are safety critical systems: air traffic control, cockpit automation, auto lander systems. And they're systems in which the people who are working with these systems are central to the operation of these systems. Breast cancer is a bit of another story. In doing all this algorithm design, mathematical modeling, and its implementation, we had a lot of biologists. And this is biology in a different sense than some of the other things we've been talking about tonight already, but like developmental biologists or cancer biologists coming to us and saying, we could really use somebody like you or your students who do mathematical modeling for the point of designing controllers. We'd like to use mathematical modeling to try to help understand what's going on in these biological systems. And so, whereas we don't really see a strong link between robotics and breast cancer, we see a strong link between the underlying algorithms, the mathematical models, and how we use those. We model protein regulatory networks. As we learn more about the networks through biological experimentation, we build those into our mathematical models, and then we use the mathematical models to simulate situations that hadn't been tested in experiment to try to, first of all, validate them. And now what we're doing is designing control schemes. So we're designing treatments for breast cancer.
I had no idea when I first started working on miniaturizing wireless sensor nodes that the first real commercial success of that would be in industrial process automation. And so now pretty much every oil refinery in the world is filled with wireless sensors that are based on the technology that was developed at Berkeley. And steel mills and wastewater treatment facilities, these things are all over the place, over 100 countries now. And they're improving productivity, reducing waste, improving efficiency, improving safety.
So I think the future is to bring a better quality of life to people with robotics. And that could have several applications. Would be civilian applications for, as I mentioned, for workers to have a better quality of life. They would have less injuries. They would have a longer life. And the second application, Shankar, is about rehab, giving ability to people to use technology to be upright and mobile. They look at us on eye to eye. They do their job. I remember I read an article, the best thing, the most important thing that makes people happy is ability to work. All these guys want to stand up, go to work, independent, sitting on a computer chair, work, come back, go home. And that, with the state of technology and robotics, should be possible, at least within the US.